and interested parties. Very good morning, everyone. So in this wonderful morning, it's my pleasure to welcome you all for the second Faculty Annual Research Session 2021 of the Faculty of Applied Science of Vavuniya, University of Vavuniya. First and foremost, we hope that everyone is safe and healthy. So during this prevailing pandemic in the country. So we are excited to be here as we managed to conduct the FARS 2021 on a fully virtual platform. Even in this very critical situation in the country and lockdown period. So I should be proud to say that the FARS 2021 is the first and foremost research conference being held at the newly born University of Vavuniya. So since there are some programs lined up before the technical sessions, so without further ado, let's move to the welcome address. So I warmly welcome the chairperson of the research session, our Dean of the Faculty of Applied Science, Dr. Mrs. Anandini Nandakumaran, to welcome the participants. So, Madam, this is over to you now.
Vice Chancellor, University of Vavuniya, keynote speakers, Professor Maharan and Dr. Sabesan, convener, distinguished guests, deans of faculties, heads of departments, directors and centers and units, senior assistant librarian, academic members, administrative executives, authors, presenters, participants, and my dear students. It's my great pleasure to welcome you all to this virtual platform on this occasion of Faculty Annual Research Session 2021 with an appropriate theme of Science for Better Dawn, aligned with the tracks of agriculture, aquaculture, animal science, computer science, internet technology, information technology, information communication technology, biodiversity, environmental science, environmental resource management, mathematics, statistics, and computing. A special welcome to the keynote speakers, Professor Pattu Maharan, Professor of Genetics, Director, Cocoa Research Center, the University of West Indies, St. Augustine Campus, Trinidad and Tobago, and Dr. M. Sabesan, Senior Database Engineer, Amazon Web Services, United States, to this event. In fact, this faculty research session called for full papers from academics and researchers in various sectors for this faculty annual research session 2021. And also call for research abstracts from undergraduate research students to have the session in Annual Student Research Conference 2021. This Annual Research Student Conference 2021 is facilitated by a AHEAD grant won by the faculty. And this Faculty of Applied Science offers 3 degree programs in which the students have to carry out research relevant to their degree programs. So this platform of ASRC creates a space to explore their research outcomes. For this annual research session, we received about 62 research papers from the authors attached to the other universities in the country, like University of Peradeniya, Postgraduate Institute of Agriculture, Rajarata University, Eastern University, University of Ruhuna, Wayamba University, Uva Wellasa, University of Jaffna, and Southeastern University, and also the research institutes as well. And these papers have undergone double-blind review process, and only 37 papers have been accepted for presentation and publication. And these 37 papers include 19 full papers and 18 abstracts. And I take this opportunity to congratulate all the authors of these accepted papers and thank them for selecting this platform to discuss their research outcomes. I encourage the student researchers to engage more on research which could contribute towards the development of the country. Finally, I thank all the reviewers, organizing committee members, editorial committee members, faculty members who worked hard to make this event success, even with this challenging pandemic period. And my special thanks to the convener FARS 2021 and to the coordinator ASRC 2021 for their tireless effort to this end. I appreciate Editor-in-Chief for putting his utmost effort to come up with the beautiful proceeding in time. Thank you.
Yeah. Thank you, Madam, for the welcome address. So now shall I call our very first Vice Chancellor, Dr. Thambo Mangaleswaran, for his address.
Dear Convener, Faculty of Applied Faculty Annual Research Session 2021, Mr. Kayanan, Dean and Chairperson of the Faculty Annual Research Session, Dr. Ananthini Nandakumaran, keynote speakers, Professor Umagaran, Director, Cocoa Research Center, the University of West Indies, Dr. Sabesan, Senior Database Engineer, Amazon Web Services, USA, Council Member, Engineer Sri Skandaraja, delegates, session chairs, Faculty Annual Research Session Committee members, senior lecturers, senior assistant librarian, lecturers, executive staffs, AR Faculty of Applied Science, AR Students Welfare Division, non-academic staffs, distinguished guests and participants, students, ladies and gentlemen, very good morning to you all. It's a pleasure to welcome you all to University of Vavuniya and participate the second Faculty Annual Research Session 2021 of the Faculty of Applied Science. This is a truly unique platform for us to come together and shape the future of development. Dear ladies and gentlemen, it's a first conference after we became a university status. Research is one of the important role of a university. The theme of the conference is Science for Better Dawn. It's meaning it's a beginning of a phenomena or the period of time, especially once considered as a favorable or origination. It's a good theme. The Faculty Annual Research Session they have selected. It's going to give really that knowledge and that their researchers' findings for a betterment of the region and the nation. Dear ladies and gentlemen, this conference is conducted new normal scenario given the COVID pandemic condition. As a theme highlights, we need to find ways to ensure development, the new normal, adjusting ourselves to the new normal condition sooner than later. This is a time in which researchers and intellectuals must come forward to engage in serious and meaningful research to help overcome numerous issues and problems that crop up in diverse fields such as science, environment, technology, information communication technology, mathematics, statistics, agriculture, and on other ancillary subjects. The conference further added value by incorporating the second annual Students Research Congress organized especially for undergraduates in Sri Lanka under the AHEAD ELTA-ELSE Faculty Development Project of the Faculty of Applied Science, University of Vavuniya. Dear ladies and gentlemen, I'm also glad to hear that many scholars, academics, and experts from various disciplines have submitted their papers. According to that committee report, they have received 62 papers, out of which only 37 papers accepted to the conference. All the papers were rigorously reviewed by reviewers who are the expert in the relevant fields. At this juncture, I thank Professor Margaret, Professor of Genetics, and Dr. Sabeshan, Senior Database Engineer, for delivering keynote speech at the event. Especially this keynote speech by Professor Margaret, targeting science and technology to support agriculture development. Even especially, this topic is very relevant to this conference as well as our context, our region as well as our nation, mainly based on agriculture. Here that I hope his experience very useful to learn these practitioners and researchers how this science and technology support to the agriculture development. We are far behind this application of science and technology, especially in agriculture development. The next keynote speaker, Dr. Sabeshan, work fast and break through with data. This is also relevant to this conference as well as relevant to our country. So definitely that very fast data is helpful to take the very effective, efficient decision making in the organization. He also going to share his experience in this keynote speech. Really, I thank them. Here, these research sessions are essential for the academic institution to create opportunities for academics and students disseminates their findings worldwide. I hope that this research session will give a better platform for discussing and sharing valuable findings and knowledge that would immensely contribute to enhancing the body of knowledge. Dear ladies and gentlemen, as I conclude, allow me to appreciate the support we have received from AHEAD since last year. And I thank you very much for this accepting grace this occasion, this especially keynote speakers and the distinguished guests and the participant. Allow me also appreciate our is invited guest. May I also thank the Dean and the staff of the Faculty of Applied Science and the conference organizing committee for having worked hard to ensure we have a second Faculty of Annual Research session with this pandemic situation. Finally, I wish you all a happy and successful conference today. Thank you very much.
Thank you, sir, for the wonderful address. So now, as per the agenda, this is the time for the release. Yeah, as per the agenda, this is the time for the release of conference proceedings on a virtual platform. So again, I invite our Vice Chancellor to officially release the proceedings by clicking the button.
Yes.
Thank you very much, sir. Now the proceeding is launched and available online. So now onwards, presenters, you can download and find your research articles in the proceedings. So good luck, everyone, for the research articles that has been published.
Thank you. Thank you.
Thank you. Thank you very much. Thank you very much, sir. So now the event is the keynote speeches. So we have two keynote speeches going to be delivered by two distinguished resource persons from overseas. So let's move to the first keynote speech on targeting science and technology to support agricultural development. So shall I request Dr. Mrs. A. Nandakumaran, Dean Faculty of Applied Science, to introduce the keynote speaker, Professor Padmanathan Umaharan. Madam, now it's over to you for the introduction of the resource person.
Pat Umaharan is a professor of genetics and the director of the Cocoa Research Center of the University of the West Indies. The center curates the International Cocoa Gene Bank, the largest and most diverse conservatory of cocoa in the public domain, is regarded as the oldest cocoa research center in the world, and houses the International Fine Cocoa Innovation Center, a university private sector collaboration interface to commercialize innovations in the cocoa value chain. Research at this center is focused on harnessing the genetic resources to enhance yield, improve resistance to diseases, minimize cadmium bioaccumulation in cocoa, improve tolerance or avoidance to climate change, as well as development and sharing of breeding technologies. Prior to 2010, he served as professor of genetics in the Department of Life Sciences of University of West Indies, involved in teaching undergraduate and postgraduate programs. Professor Umaharan has 35 years of experience in studying the genetics of resistance to bacterial, fungal, and viral diseases affecting a number of crops, including cocoa. He has successfully supervised 21 PhD and an equal number of MPhil students. He has published extensively with over 150 publications in refereed journals. His work has led to the development of resistance cultivars in cowpea, pigeon pea, hot pepper, anthuriums, and cocoa. He serves as a jury for the UNESCO Life Sciences Prize. He has also served as Deputy Dean in the Faculty of Science and Agriculture, an expert in the CARICOM appointed expert group working and advising on biotechnology and biosafety, member of boards of governance of the Caribbean Industrial Research Institute, and the chairman of the Cabinet appointed committee on establishing a virtual center of excellence in agriculture and biotechnology. Above all his excellence in his career, he was my undergraduate teacher at Eastern University in 1985-86 period. In fact, he is one of the best products of University of Peradeniya. I found him as one of the best university teachers I came across in my educational career. I am so privileged to introduce him in this forum. Sir, now this platform is yours. Thank you, sir.
Thank you very much for the kind introduction. I'm going to share my screen. Okay, I hope you all can see the screen.
Yes, Professor, we can view here.
Okay, so let me okay, so okay, the Vice Chancellor, the Deans, faculty members, esteemed researchers and presenters, students, and specially invited guests. A pleasant good morning to you all. It's very late in the night here in the West Indies. Let me first congratulate the Dean and the conveners of the conference for organizing this in such a very difficult time. Conferences allow the confluence of ideas, foster relationships and collaborations between researchers, and it creates opportunities for researchers to shine. Being a Sri Lankan, I am extremely proud and honored to be invited to speak at this forum. I'm a proud graduate of the University of Peradeniya and had short stints as assistant lecturer in the University of Peradeniya and later at the Eastern University before I departed the country 35 years ago. Having been away for 35 years, I wondered what I can speak about that would interest you in Sri Lanka. Having worked in another tropical island state, I thought that sharing some of my experiences as professor, researcher, and more recently, the director of the Cocoa Research Center may allow some discussion. I would like to explore during this presentation the role of research in diversifying the economy in this technological era. So, so to start with, I would like to first give an introduction to the University of the West Indies. The University of the West Indies is a regional university that supports 16 countries in the Caribbean. We have 4 campuses and an open campus. I am situated in the southernmost campus in, sorry, just a minute, I think. Right. So I am situated in the southernmost campus in Trinidad and Tobago. And most of you all who don't know Trinidad and Tobago may know that Trinidad and Tobago is home to the cricketer Brian Lara. So in today's presentation, I would like to touch on 4 points. One, the first about research. Second, about technology transfer. Third, about building an innovation ecosystem. And then I'm going to use some of my experiences in the cocoa sector to showcase some of the things that we have experienced at the University of the West Indies. So the first, I'm going to talk a little bit about research. And I regard that there are 3 different kinds of research. One is the blue skies research, where this is curiosity driven. It is does not immediately have any real world applications, but can create disruptive technologies. Much of the developing countries do not embark on blue skies research. Much of our work is centered around problem solving research, which is of an applied nature and leads to practical practical solutions to problems that we face as humanity. But I'm going to talk to you a little bit more about a strategic research and innovation system that we need to build, which is beyond a problem-solving research. I'm going to show some of my experiences over the years to showcase to you why a different kinds of approach is required if you want to really support development in the country. So this is an early work that I had done in trying to look at industry by industry. And I was looking at the industry that produces vegetable cowpea and black eyed peas. And at that time, there were 2 major diseases that were devastating the industry. One was the cowpea severe mosaic virus disease. And then the other one was Cercospora leaf spot, caused by Pseudocercospora cruenta. So over the years, I think we have identified resistance. We studied the genetics of resistance, and we established a breeding program to develop varieties that are resistant to this disease. I think the results were impressive, I would say, but in many ways, in some ways, it was disappointing because very often research to have the required impact requires, in addition to the research findings, other support systems such as policy support, seed production, and other marketing approaches so that the innovations that you create can have an impact on the ground. So, so this was one of my earlier experiences as a researcher. Then we went on to, the slide is not moving, sorry. Okay, so then we went on to looking at another crop. In this case, it was an anthurium. It's an ornamental. And we looked at the industry, and there were several problems that was affecting the industry. Trinidad and Tobago had a very buoyant export industry of anthuriums into the North American market, and it was earning considerable amount of foreign exchange, only to be devastated by two diseases, the bacterial blight disease and the bacterial leaf spot. The first one caused by Xanthomonas and the second by Acidovorax. And then there was also the problem of nematodes that were debilitating the productivity of the plants. We also wanted to improve the vast life so that we can export to longer distances. And we also wanted to create novel colors. And this is where I got into biotechnology research. And in this case, I think the difference between the first and this case is that in this case, we worked with a large farm, a 16-acre farm that produces anthuriums. And we did what we call a participatory breeding exercise along with the private sector producer. And we were able to develop a range of varieties with resistance. So this one was a little bit useful in that because the private sector was involved in the developmental process, there was better adoption of the varieties quickly by the private sector. And it created improved productivity. It provided a comparative advantage to export into the international markets. But then still there were problems of not having enough propagation systems to rapidly multiply the varieties to meet the needs of farmers. There were problems of extension and so on. So there was realization at that time that even though you involve the private sector, but that itself is not a sufficient condition to create the kind of impacts that you need on the ground. So this is where I come to this topic about strategic research and innovation. You know, what this is about is that here we look at the industry in a holistic way. So it's an industry approach. It requires foresighting to try to understand what the global challenges are now and what would be the challenges in the future. What would be the demand drivers into the future? You do an environmental scan, you look at a strategy, and you conduct research in a multidisciplinary way involving a number of different researchers, not only in agriculture, but in engineering, in social sciences, and so on, so that you create an integrated innovation system that can actually become functional on the ground and create value. Partnerships are very essential in this, and you have partnerships along the value chain so that you can improve the value of your product. You have partnerships in research, not only internal partnerships within the university, but also external partnerships with external organizations and so on. And I'll give you some examples as I go along. And then funding the research is critical. Entrepreneurship, having done all the research, if it's not commercialized, it does not really have an impact on the ground. So it's very, very important for this to be converted into the markets. And continuous improvement is also very important. So this strategy is what I think we have been employing in recent times. Okay. The slide is not moving. All right. Okay, so I'm going to talk a little bit about, we talked about research, but I'm going to talk a little bit about technology transfer. Now, traditionally, technology transfer is thought as a very in a linear way. You start with research on one end, then you have technology organizations converting the research into technologies and transferring it. Then the industry taking up that research and converting into commercial products. And then farmer extension happens and the technology is taken to the farmer finally to create value. So that is traditionally the way the innovation systems, technology transfer systems work. And very often this system doesn't really work well because institutions have a way of building very hard walls between themselves. The research doesn't talk to technology providers don't talk very well with the commercial enterprises, and the commercial enterprises don't talk well with extension. And as a result, you don't have the impacts that you intend to have. So that's, and many countries have looked at this and they have developed their own approaches to overcome this. And one of the examples I'm going to give is the land grant university system in the United States of America. And in the USA, you have the land grant system where the institution does not only do teaching, they do research, they do technology development, they do commercialization and extension all in one. So the public sector, in this case, the university, controls most of the technology transfer apparatus, and then the value is given to the farmer. The Silicon Valley, on the other hand, operates a slightly different system. And here you would see that the universities only work on research and technology development, but early stage technologies are now transferred to the private sector, which now takes it on, develops it, and commercializes it, right? So in this case, public sector plays only a part of the role, and the rest of it is taken over by the private sector. Now, if you look at countries such as Cuba and so on, which is very close to us in the Caribbean, they have a very good system, but it's a very centralized system where most of the work is done in the public sector in this case. And here you would see that all research, technology development, commercialization, everything is done in the public sector and is transferred to the private sector. Then if you take the multinational companies, they do everything in a sort of private sector, in the private sector. So you have research, technology development, commercialization, everything happens in the private sector. So different countries have developed ways in which the technology transfer system can be harnessed so the value can be created to the end user. Okay, stuck again, just a minute. Okay, yeah, so I'm going to now, third point I'm going to make is about the innovation ecosystem. How do you build an innovation ecosystem in a developing country using some of the understanding of the kind of research we need to do, the kind of technology transfer system that we need to do, and so on. And so here in this case, we say that the innovation systems, ecosystems are very important so that the information and research findings that you created or the ideas that you created are transformed into reality. And reality means that it should lead to increased production, increased business activity, increased export, and so on, whatever you want to. And to do that, you would need partnerships. You need to have policy, the right policy environment or enabling environment. You would need open innovation systems. You need better partnerships along the value chain. You need to get funding mechanisms correct. You want the right kind of reward systems so the whole system functions. And very often I find that in many countries, including in Trinidad and Tobago, the reward systems are not done correctly. So they reward people for the wrong things. And as a result, the systems don't really advance. Then you need technology transfer, commercialization, creating spin-offs, business development and technology. And this is why I was saying that you need a multidisciplinary approach if you want to use this to create value. Okay. Right. Okay, so this is a pictorial diagram showing what an innovation ecosystem should look like. In this case, you need an enabling environment that you need to create through policy. It could be policy at the national level. It could be policy at the regional level. It could be policy at the university level, so that you enable the whole process of science to have the right impact in the whole process. The science leads to technology development, that results in technology transfer, and that ends up in commercialization of these technologies that creates value to the farmer and businesses. So this is very important. Sorry, I think this thing is a bit getting stuck. Okay, so I'm going to give an example based on the understanding. At the Cocoa Research Center, we have been having had this experience in my early research career. I decided to, when I took the leadership of the Cocoa Research Center, I decided to look at the things very differently. So we looked at an industry approach. We worked with the entire value chain, and we identified some of the problems that exist in the industry that needs to be overcome so that we can become an exporter of value-added products, and that required yield improvements, risk mitigation measures, quality management systems, better marketing systems, and so on. So we identified those. And then we said that if we want to really make this into a practical reality, you need to bring three major players together. You need to bring the private sector, you need to bring the university, and you need to bring the government. And this is very often referred to in the literature as a triple helix approach. And we bring together, and we created what we call an innovation center that brings these organs together in a collaborative fashion so that you can create the innovation ecosystem in which innovations can foster. As I said, we call this the triple helix model. And it basically, the innovation center is actually an engine that capitalizes on the strength and opportunities that resides within the sector and converts it into profitable businesses, and so that you can, and export businesses, so the country as a whole can prosper and grow developmentally. And this involves stakeholders across the value chain so that it allows the value chain stakeholders or the actors to be energized. And therefore, on one end you have the farmers, and the other end you have the consumers, and you need to have all the value chain players coming together too. We also, is very important for most countries, is to have win-win research partnerships. We have been very, very successful in establishing research partnerships with a number of universities in France, UK, US, and so on. And this allows us to really capitalize on deficiencies that you have very often in small island developing states, including Sri Lanka. I would say is a small island. You have deficiency on capacity. You don't have enough capacity in terms of all sorts of technologies. And very often you need to establish win-win collaborations. It allows you many advantages. It allows you new technologies to be brought in. It also allows you the opportunities to win grants, in competitive grants. So the Innovation Center that we have created at the Cocoa Research Center allows us to showcase all the innovations that we have along the value chain that we have created. So we have a model cocoa orchard that we showcase that we can produce 3,000 kilograms per hectare compared to what farmers get, about 300 kilograms per hectare. We offer training in value addition. We have incubators, technology incubators, business incubators, to transfer the technologies to businesses so that they can end up producing products that they can market locally, regionally, and internationally. So this is some of the pictures of our innovation center that we have created. And these are some of the equipment that we use. These are some of the technology incubation. These are some of the trainees who are working in the technology incubators, producing various products out of cocoa and so on. And I would like to summarize now. And innovation centers, I think, are a very useful tool particularly for developing countries to strategically align their objectives with impacts on the ground, creating opportunities for enterprises to enter into the export market. And Singapore has done it very well, setting up these innovation centers, and they have been very successful. So innovation centers take an industry approach. They involve partnerships, public-private university partnerships, involve partnership between value chain actors. They embrace a strategic research and innovation approach that I had described before. It also creates the kinds of outreach that is required for the technologies to be transferred to the private sector through technology incubators, training services, technology services, and so on. So with that, I would like to thank you all for listening. And I wish you all a very successful conference going forward. Thank you.
Yeah, thank you very much, Professor, for the wonderful presentation you delivered, covering all aspects from inspiration to dissemination in the agricultural research. So then let's move to the second keynote speech on work fast and breakthrough with the data. So going to be delivered by Dr. Manika Vasagan Sabesan. So here I request Dr. Nagulan, Senior Lecturer attached to the Faculty of Applied Science, to give a brief introduction about the keynote speaker.
No.
Thank you, Suganya. Good morning, everyone. It's a great pleasure to me to introduce our keynote speaker, Dr. Sabesan, a dear friend of mine, a prominent database researcher, and a great human being. So Dr. Sabesan completed his undergraduate degree specializing in computer science from the Department of Computer Science, University of Jaffna. He completed his PhD from Uppsala University, Sweden, in 2010. His primary research area in database system, especially in query optimization with web services. He worked in Oracle, world's largest database management company, as a software engineer for around 7-8 years. And currently, Dr. Sabesan is working as a senior database engineer at Amazon Web Services. And he continues his research and development towards automated performance tuning with various database engines. And ladies and gentlemen, please join me in welcoming Dr. Sabesan to the conference. And Dr. Sabesan, now the platform is yours.
Thank you, Dr. Nahulan, for the kind introduction. I will share my screen. Could you guys able to see my slides?
Yes, sir.
Yes, yes, sir.
Yeah, thank you. Hey, good morning, folks. Today, I plan to deliver the the talk about the work fast and the breakthrough with the data, because my background is from the database research and my industrial experience also the database research. If you see the title, if any lights blink on your head, that's fine. That's great. We can discuss more. If there is no light blink on your heads, no problem. We could learn together. That's the purpose of this one, the talk. Therefore, mainly my agenda of this talk, the first 10 minutes, I'm going to talk about how to monitor the high volume data flow, those like a stream data. And I will explain some industry standards and what are the things in practice in industry. And the next 10 minutes, I'm going to talk about how the data tunings and recommendations are happening with the industry. Then at the end, we could have a quick Q&A sessions if you have any questions. That's the structure of my talk. Before we slowly get into the talk, even from the first professor's keynote speech, you could hear about how the technology involvement with the agriculture industry. A lot of tools are going to be used and a lot of technological involvements with is happening. Because of those things, and the mobiles and all the navigation devices and all the medical devices and all the web related and cloud related things, we're having a huge amount of data. And the data have two big properties. They are continuous like a stream, and also they're coming in a very high volume. This is the property of this data. And also in this talk, I'm not talking about if it's a streaming data or the continuous data, how we are going to extract those data from the streams. I'm not talking about it. Instead of that one, if we extracting the data and then what we're going to do with the data, that is the part I'm going to cover, because the first part is a completely different area of the research. And another dimension or another property of this kind of high volumes of the data, they have multi-dimensions, meaning a medical data or any other some agriculture-based data or any other astronomy data coming from a telescope or from an aircraft. They're having around more than 100 fields. That's why we are calling as a multi-dimensions, and those fields need to be analyzed. Say, for example, scientists may be involved on these different properties of a particular data. And for them, it's maybe their scientific thing they need to get a result. But as an engineer working on the data, for me, all these things looks like a data and with a different with a different dimensions. Therefore, that's also another challenge with this kind of, these are the properties and the challenges of these days with the high volume of data from different electronic gadgets. Yep, I'm talk about the high volume of data and the properties. So what's the problem with that? Okay, we can extract the data. Then what we need to do? The problem is the data is having an information. Therefore, we need to manage the data and we need to process the data. Say, for example, scientists or doctors or engineers or accountants, whoever they're having in their field, they're having a different kind of data, and they need to manage it and they need to process the data. Therefore, and And these data should be stored in a structured format. In a minute, I will explain what this structured format I meant. And with these industries, I think it's not new, this RDBMS, relational database systems. These are existing starting from 1970s, I could say. And periodically is developed, and a lot of databases around is developed, and ecosystems around those things are developed. And now it's become a huge system. We call them as a relational database management systems. And even though there are different kind of NoSQL databases and different kind of databases comes, but for different purposes, still in the industry, the RDBMS is more desirable and widely used system to store the data in a tabular format. By the tabular format, what I mean is a simple example, I could say. Relational databases, they store like a tables, and a database, in a very simple term, we can tell a database is a collection of tables. They're having a rows and they have columns, and in between the tables, they have relationships too with the students and departments. I try to give an example from a university background. Those are the properties you can simply see that with those different tables in a relational database systems. In mathematical notations, every table is called as relations. We call every table represent a relation. Therefore, all these set operators and all these things, mathematical operators can be applied on these tables. And a minute ago, I mentioned about the structured format. Therefore, here the structured format means we are storing in a row-based data set in a table. Therefore, now we store the data, just for an example, in a table, as I mentioned before, a table called students. Okay, we store the data, then what we can do, because we have huge amount of data these days, we're having terabytes of data to be stored. Therefore, once we store the data, that's not good enough. I need to process something, and time to time, I need to access those data in a very programmatic way. I mean, a few decades before, we can save it on our regular files in the papers, then some file systems comes up, then we couldn't manage with the file system, then the data grows huge. Therefore, to access those data, we call them queries. For a scientist, it's maybe a question or a process to apply on an existing scientific data to get some results. But eventually, if you come to the database, it's become like a query. Therefore, for those things, we're having a very structured query languages. That is also in the industry, still on the industry practice. Therefore, we need to get any other columns from the existing tables, and we can specify any other simple predicates with the where clauses. But this is a very simple query I may explain to you. As I mentioned before, every table is considered as a relation. All kind of relational operators can be applied on that. Therefore, the where clause become more clumsy and more tables will be involved. Therefore, with that accessing data, the big problem we are seeing these days with the streaming of the data and the high volume of the data, the queries have become more complex. Sometimes we could say around more than 6,000, 70,000, 6,000 up to 7,000 characters of long queries with a very complex operations. That's the first thing. And the second thing, the number of queries, the size of the queries to extract the data from the database started to increase tremendously because of these requirements of the mobiles or if you look making just a search from a mobile phone, it's end up making a query back from a database. Therefore, this kind of queries seems to be getting increased a lot. And also the people losing the patients these days, they want to get the results fast. And for some processes, definitely we need the results fast too. Say, for example, nowadays in some COVID testing, and we need to get the results as soon as possible. Otherwise, we don't know what's going on with the patient. Therefore, in such circumstances, this is some simple real-time examples I'm saying. Therefore, this is also one of the challenge with the accessing the data, getting the results fast. That's why we need to think about how we are monitor the performance of a query. If it's a query is issued, okay, fine. It looks like, okay, it will give the data, but I can't wait for a day or even minutes these days, even milliseconds, even less than milliseconds, I could say, for the simple queries we need to rely on these days. Therefore, that's why the performance monitoring parts come in. The industry is heavily needed to monitor the huge amount of data is coming, flows as streams. Therefore, these are some basic important questions we need to answer if you monitor the performance of the data retrieval. Okay, how to monitor? If you want to monitor, if it is a person, we can monitor that person is growing or not using some metrics, say for example, height. Similarly, for this performance of data retrieval, we need some performance metrics. Those need to be collected from the database. And the huge number of queries running on a server or in a cloud. Therefore, we need to think about it, how we can automatically collect them in a scalable way without affecting any other regular operations running on the system. And that's the first step, because the customers are paying for the databases. Therefore, they don't want to disturb their day-to-day activities. Even the bank activity is quite vital and very important. If a simple, if you go out for a few seconds, is a big impact caused by such things. And the third one, how often we need to collect those metrics without degrading the performance. That means that if you're collecting all the time these performance metrics, then I don't have enough resource like memory or the CPU is not good enough, or we are running out of those resources. Therefore, we need to think about it, how often we go back to the database and collect those matrices. These are the very basic thing we need to think and address when the engineering something for the performance. Therefore, let's see how this works, or what kind of technologies we are using it for collecting those performance metrics. Look at the simple scenario. Just I start with a very simple example. There are 3 users running on a database that a lot of data are stored. Then you could see that the pink blocks. These blocks meaning those queries or the questions running fast and get the results. And if you think about these green blocks, they look like a very fast queries, but altogether, if you see that the number of query execution seems to be very less when comparing with the pink blocks. And the third category of queries are they are slow queries. That means they take a lot of time to execute and get back the results. Therefore, we can't monitor all the executions of the queries. Instead of if you see that the very downs at the bottom, I put a timeline. That means we need to monitor from 9:30 a.m. at 32 seconds. Then every 1 second, we are every 1 second, we are collecting these performance metrics. Therefore, it's a kind of a sampling mechanism we are doing it. Therefore, with the sampling, what's the thing you can observe? Say, for example, with the user 2, some of the queries may missed the metrics for those, or while they're executing it, we couldn't capture it because that falls in between the timelines. Therefore, the few of outliers will happen like that. But for the slow queries, definitely we catch it because it's a long running query that mostly the 1 second is good enough. Therefore, basically with this sampling technology, we can able to get how the workload is running on the overall system. Therefore, by this one, I will get to know how many FARS queries I'm running, how much heavy workload is running on my system, and that kind of things with the sampling workloads. Sampling technologies help us to find out, and this is the one is implemented while we are collecting the performance metrics. And then, okay, fine, we are collecting the metrics, we get it in a scalable way, and in every 1 second samples. Then we need to visualize it. A human need to know how my system is heavily running or is okay to run or something like that. Therefore, for those things, we are using some metrics called active sessions. Is a metric. Therefore, I don't want to go detail on it. This is basically what is telling us how busy the system is, rather than what's really going on, or is an implication of what's the real workload is going on the current system. This example is on a busy day with the database. Say, for example, if you consider some real-time example, if there is in a new year in Sri Lanka, there is a bank and a lot of transaction, a lot of people maybe deposit the money or they extract the money, and therefore there is a lot of queries from the ATMs or from their mobile devices through the browsers, and all these queries are coming to the different servers. Therefore, you could see that this is a very high workload. It's running around here. Therefore, this is one snapshot. Is RDS AWS performance insights, helping to the customers to understand how's the workload is running on their current system. And at the bottom, you could see that they are listing the top queries they are consuming a lot of resources from the system. Therefore, say, for example, this commit query is taking a lot of time here. Therefore, the customer then could understand, okay, this is the query is consuming a lot of resource from my system. Then I could think about it, how to resolve those issues. First, this will help us to identify who's the culprit, who is making most resource consumption in the system. Therefore, this is some simple snapshots from the RDS AWS RDS. And similarly, Oracle and SQL Server, they have their own way of things, but the underlying technology is a sampling related mechanisms, and they have some way of visualizing it through the average active sessions. Now, say, for example, as I said before in the previous talk or previous slide, like we find out who are the culprits or who are the top guys consuming most of my resources, and then I find it. Then the next step is how to tune it, or how I can improve that question to running that query fast or get back the results in a fast way. Commonly in industry, we could see that the plans to execute a query, we having a query plan, how to execute it is slightly more complex, but there is a plan how to execute. Those plans are determined by the tables, columns, and row statistics. Therefore, those statistics sometimes stale. They are wrong. They need to be corrected. And similarly, like a book, the index in the books, you can see the index on the back to quickly go and see that particular page. Similarly, we have database indexes. Those database indexes may miss from the columns. And even sometimes the database, even Oracle these days having more than 100 database parameters to tune. It's like a knobs to improve the performance. Therefore, sometimes those parameters are not correctly tuned. Therefore, because of those things, also these queries are running slow. And the fourth common part is like those are very poorly written queries, because sometimes the software developers, they don't have the proper database knowledge. They are writing the queries in a wrong way. Because of that one also, they are reducing that. Because of that one also, the performance degrades. Right. Next, I'm going to I'm going to show you a scenario, and just I want to ask a question on that too. Therefore, please listen, view carefully. I'm going to ask a simple question based on that scenario. The fun part starts. Okay, now I believe everybody see the scenario. Therefore, the next slide, I'm going to make a simple questions to you. You guys could answer me on the chat. Therefore, it's kind of a multiple choice questions. What did you infer from this previous scenario? These are the answers. Therefore, you could type the numbers. We could take a 1 minute for a quick break, or I will wait for 1 minute and see that what are the answers you could come up with. You can type the numbers 1, 2, 3, 4 on the chat. I don't see any of these numbers. Okay. Interesting. I see a few threes. No one interested? Okay, I have time limits, therefore I'm moving on. Yeah. Actually, the problem is, yeah, it's an interesting observation too. Okay, it's a quite obvious observation from this slide. But the real problem here, the human is involved with this tuning. Therefore, when the query starts fast and they scale up, then the human couldn't handle it. Therefore, the main issue is with the scaling issue. Therefore, traditionally, those tuning are handled by the human experts, database administrators. But nowadays, it's pretty hard to handle those things because of scalability issues. They couldn't handle each and everything because it's quite complex. And it's because of those things, they couldn't involved on that. That's why the industry required an ecosystem. That's a case I'm thinking, okay, if the human experts couldn't do that, then the question from the industry, so what we can do now? What's the next thing we can improve this performance? Automated sizer provided by the Oracle. Therefore, here is no human interventions is involved. Therefore, these SQLs are collected from different sources. I don't want to go through the details because I don't have time, but that is the bottom line of these things. Therefore, then some automatic tuning process is happening and is completely automated, and they provide the recommendations. By the recommendations means how we can speed up these questions or the queries. What are the possible ways to improve these queries? This is an existing standard. I'm work on some parts of that one too. Okay, fine. Now, this kind of tools providing and provide the recommendations. Therefore, the questions comes back. Okay, shall we blindly implement those recommendations? Because I don't know, because a huge amount of data, around millions of customers, they are using this database. If I implement some of these recommendations, I have no idea what will have to happen to my system. Is to generate to any kind of system. It's maybe crash, or it may be slow. Therefore, normally the customers or the database administrators who managing the database very hesitant to implement those recommendations. Therefore, the next step we need, find some way to validate the recommended action. Therefore, for those, there are two big kind of things exist. One is called rule-based tools. That is called SPAR. That is also developed by the Oracle, SQL Performance Analyzer. Basically, what they're doing is they're having a they're keeping two different systems. One is the production, and they're creating another test system. The test system is exactly the kind of a clone of the production. Therefore, they execute a workload and then implement the changes. And before implementing the changes, get some metrics and implement the changes and get the same metrics and compare it apple to apple and see that how the performance goes up or goes down. But this have some pros and cons too. This is one of the simplest way to do, but in the con side, it is not exactly represent the customer workload because they are running a certain amount of SQLs and they don't have any proper, they are not a proper representations for that. But this is the current one. We are using it currently for such validating these recommendations. And another one is currently in research and development, some mission-related algorithms, like how to mimic the optimizers or the databases with the previous knowledge through the learning, or some index advisors. Say, for example, you could, if you searched around, the Microsoft developed and published a lot of research papers for the index advisor. Those try to do by learning, and they come up with some new knowledge, and on those knowledge are helping us to validate these recommended actions. I think I almost about the time. Therefore, at last, I could spend some few minutes. I don't know, maybe 5 minutes left for me. Any other questions or answers you could ask me, or you can just type me on the chat. Therefore, if I know the answer, I will answer it. Or otherwise, talk to me over the offline using my email or through my LinkedIn. I'm happy to collaborate with any other R&D or machine learning related technologies with any performance tuning or performance measuring, that kind of things I'm love to do. Therefore, I'm open for questions or any other discussions, comments.
Thank you, Sabaisan, for the very informative speech.
Yeah, thank you very much, Dr. Sabaisan, for the very attractive presentation. So this is the time for discussion on the keynote speeches. So shall we come from the first? So first of all, shall I ask Professor Umaharan to answer the questions coming from the participants? So participants, then if you have any questions, please raise your hand. So we will facilitate you to ask the question one by one. So I have received one question in the chat box. So thank you for an excellent presentation, which is more useful for the country like ours. It is very much essential to adapt the model like a triple helix approach. So you have talked about Cocoa Incubation Center. So I would like to know a bit more about how it functions.
Okay, thank you. Thank you for the question.
The question is from Dean, Faculty of Applied Science.
Okay, thank you for the question. I think, so our Innovation Center has it's a model cocoa orchard. It has a factory, a value-added factory. It has incubators, technology incubators, and it has business incubators, and it also has a technology service center. So it's all of this functions together in a coordinated way. And so we are able to support businesses. We are able to support businesses that, sorry, I think, yeah, we are able to sort of incubate businesses that that are startup businesses, we'll call them. We provide training, apprenticeship training to farmers, value-added producers, entrepreneurs and so on in business incubation. We also provide a lot of technology products. We produce intermediary products like cocoa liquor and cocoa butter, cocoa nibs and solids to supply to small scale chocolate producers. So it's a sort of comprehensive center. The overall objective of it is to really support innovations along the entire value chain, and also to support new businesses to establish themselves and get into the export market. So we also do support services such as branding support and so on, so that they can get their products into international markets.
Thank you, sir.
Thank you, Professor.
Thank you.
And the participants, then if you have any questions, please raise your hand, then we will facilitate you. So no more questions from participants? So if you don't have any questions, then we can move to the second keynote speaker, Dr. Sabesan. So participants, then if you have any questions from Dr. Sabesan, then you can ask now. Please raise your hand and you can ask straight away the questions to Dr. Sabesan.
Dr. Sabesan, this is from Dr. Naulan. So the non-relational databases, say NoSQL databases, most popular MongoDB. Their representation actually are different, say graphs or sometimes object-oriented, not like relational databases has relations. So usage still RDBMS, relational database management system, mainly used in industries. So what kind of future for non-relational databases? So any difference for the performance monitoring procedure you explained in your speech?
First of all, thanks for giving this opportunity to present those things. For your question, if anything involved with transactions, therefore, say, for example, the banks or that kind of things, for very fine-grained control, we should have the relational database systems. And for some of the systems, as you mentioned, this MongoDB, right, NoSQL, and they have sometimes JSON kind of structured kind of data. And these are not controlled by the transactions or asset properties, the consistency information. Because if you think about a bank transaction, if you put in money and right away it should be reflected on your account. If you take it back up $10, the $10 need to be deducted from your account. But some of the applications or some of the scientific or industrial applications, they don't need this kind of properties. For those applications, they are okay with NoSQL thing. Therefore, we couldn't see that, or I couldn't comfortable to say that RDBMS is going to replacing the NoSQL or NoSQL going to replace the RDBMS systems. Both going to exist for different kind of applications. And of course, for sure, for these NoSQL also, they're having different kind of mechanisms for performance tuning as well, basically on the querying, but even there is even slightly, but it's a completely different way, because here we are thinking about row-based data sets, but on the NoSQL side is a kind of different structures, and the queries may be different. Therefore, it's kind of a different set of performance improvement too. But the fact about the performance, the monitoring, and the tuning is a common fact, regardless of whether it is a RDBMS or a NoSQL database. That's my answer. Did I answer your question?
Yes, thanks.
Thank you. And any other questions from participants? So we have enough time to start the technical session. So if you have any question, then you can freely ask from Dr. Sabesan. All right, then, if you don't have any question, it's okay. Thank you very much for both the keynote speakers, Professor P. Umaharan and Dr. M. Sabesan, for being with us. Actually, Professor Umaharan has joined even in this late night from West Indies. Thank you very much for both of you. So now we are nearing the end of inaugural session. So well, as you all know, and initially these arrangements were made to conduct the conference physically. However, due to the unexpected COVID outbreak, then we have to make the conference virtually. So finally, all the helping hands put together to make the event a success. So this is the time to thank the people, those who helped in several ways. So shall I ask the convener of the research conference, FARS 2021, Mr. M. Kayanan, for vote of thanks.
Thank you, Dr. Sania. Good morning to all. On behalf of the conference organizing committee of FARS 2021, I'm deeply gratified to deliver the vote of thanks at this remarkable national event on 15 September 2021. I'm thankful to Almighty God for blessings and grace who keeps us in good health to participate in the event amidst the pandemic situation in the country. I would like to thank the Vice Chancellor of the University of Vavuniya for providing administrative support in organizing FARS 2021. We have been fortunate to have two renowned identities, our respected keynote speakers, Professor P. Umaharan from Trinidad and Tobago, and Dr. M. Sabesan from the USA, for delivering keynote speeches despite the time zone differences. Their field and industrial experience paved the way to understand the current trends in the respective disciplines. I sincerely appreciate the editor-in-chief of FARS 2021 and ASRC 2021 for his excellent job. His dedication and hard work have been reflected in the conference proceedings. He continuously strived for more than 4 months to maintain the standard of the conference proceedings. Also, I thank the co-editors for their commitment to bring the conference proceeding on time. My special thanks goes to all authors, co-authors and presenters for their contribution at FARS 2021 and ASRC 2021 in the form of full papers and abstracts. I wholeheartedly congratulate them for being selected to present their research findings at this National Research Forum. I appreciate the service of reviewers who were an integral part of the review process to provide critical comments to authors. I want to extend my generous thanks to session chairs and session coordinators for accepting our invitation to conduct the parallel technical session completely virtual. I take this opportunity to thank the coordinator of ASRC 2021, Head Department of Physical Science, for their immense support to hosting the virtual mode of the conference. At this juncture, I cannot forget the technical chair, Dr. T. Kogul, and his team for their untiring support in conducting rehearsals to orient the presenters and keeping the event alive via online platform. I gratefully acknowledge the grant received from AHEAD Faculty Development Project to support the event. For that, I am thankful to the project coordinator, Dr. S. Vijay Mohan, and activity coordinator, Dr. Nagulan, to make this conference more successful. A big thank you to our dean, our faculty dean and conference chairperson for her involvement and noteworthy support at various instances throughout the conference arrangements. Finally, I thank conference committee members, academic, administrative, and non-academic staff for lending hands in organizing this event. I thank all the people who helped me either directly or indirectly to make the conference successful. Thank you all. Thank you to all participants for attending the conference virtually. I believe that the FARS 2021 and ASRC 2021 will build a memorable and productive discourse for all who are part of this event. Thank you, Almighty God. Thank you.
Thank you, Kanan, for the vote of thanks. So now let's move to the technical sessions. So as per the agenda, the technical sessions will be scheduled, will start at 10:30 a.m. Sri Lankan time. Now the time is 9:45 here. So we have another 45 minutes to go to start the technical sessions. So there are two technical sessions going to be conducted parallelly. So one is the FARS, so faculty annual research session for full papers, and the second is the annual student research congress ASRC for abstracts and poster presentations. So there are two Zoom links already sent for the respective sessions and also available on website. For your easy reference, we will put the Zoom links in the chat box too. So presenters and interested parties, please click on the appropriate link to join the relevant technical session sharp at 10:30 a.m. Sri Lankan time. So there are 5 sessions under each FARS 2021 and the ASRC 2021. So this will be chaired by the relevant session chair and the academic coordinator who will look after this technical assistance. So thanks again and good luck with your presentations. So still you have to wait 45 minutes to start to join for the technical sessions. Thank you very much now. This is the end of the inaugural session. Thank you so much.